Okay, good morning, good afternoon, everyone, and welcome. As I mentioned, my name is Emma Dutton, and I will be your facilitator for this webinar today. Our presenter is David Feist. Thank you all for joining ANAB for our complimentary webinar on ISO IEC 17025 and ISO IEC 17020. Which is the right standard? Please note that we are recording this webinar, so it will be available for viewing in the future. Just a few logistics before we get started. Due to the high attendance, everyone will remain muted for the duration of the webinar, so please enter your questions into the Q&A box. The Q&A box is a panel that you can find on the right-hand side of your screen, and you should see a section where you can just type in your question and hit the send button. We have a planned time at the end of the webinar to address or answer all your questions. So we'll be accumulating those questions until the end of the session. So a little bit about the presenter. David is an accomplished quality professional with experience in multiple disciplines of international business, manufacturing, process mapping, organizational effectiveness, emergency management, for the business community. He also does Six Sigma quality improvement methodologies and total quality management and software development. He is a former owner of China Sourcing, Inc., an Asia Pacific manufacturer of industrial products sold throughout the U.S. industry with over 20 years of experience in project management and large-scale project implementation. He is a consultant in laboratory systems on manufacturing, international product teams, software validation, and project management. In addition, he's a senior accreditation manager and a lead assessor for ANAB in both 17025 and 17020. He was a lead assessor for DoD, ELAP qualification assessments, overseen by NAVSEA, which is the Naval Sea Systems Command. Mr. Feist established and ran 13 laboratories globally, guiding them through the ISO IEC 17025 registration process. He has led accreditation assessments to 17025 and 17020 standards, including 10 DoD ELAP assessments. He has also been technically witnessed to qualify 3 environmental NELAP assessors for environmental laboratory accreditation. He has led multiple training courses for private clients, qualifying them for international assessment of laboratories and inspection bodies. In addition, he currently serves on the technical advisory group as a technical lead for ANAB with input on both their ISO 17025 and ISO 17020 accreditation process. So welcome, Dave. I'm going to take just a second to transfer control to Dave so he can continue and present the rest of the webinar. There you go, Dave. It's all yours.
Okay, that's great. All I got to do is figure out how to advance the slides.
So over on the left-hand side at the top where it says View, you can pull down thumbnails, and then you can see the thumbnails on the left-hand side, and you should be able to advance that way.
Perfect. Okay, so let's start off with looking at the objectives of what we want to do today. And first was, I want to make sure that we all have a view for what the conformity assessment standards are. So we'll talk about those a little bit today. We're also going to talk about what are some of the things that are common between these two standards. Yes, there are some differences, but there are more in common between them than might appear at first glance. Now, we'll also talk about key differences between the standards because 17020 concentrates a lot on intellectual knowledge and decision making, whereas 17025 focuses much more deeply on testing, calibration, dimensional measurement, and very concrete results. We're going to talk about what the accreditation and assessment process is that's utilized not only by ANAB, but by accreditation bodies around the globe. And then we're also going to look at what are some of the key factors that we should consider when we're selecting a standard, because this is a question that I get quite a bit when I'm talking with people about the use of 17025 accreditation and the use of 17020 accreditation. So let's take a look at that. First thing we're going to look at is something we call the ISO Casco toolbox. Now, at the top of this, you're going to see where we talk about requirements for accreditation bodies. ISO 17011 details all of the things that we as an accreditation body have to do to institute and execute standards and accreditation for conformity assessment bodies. Now, you'll hear me reference conformity assessment bodies several times today. Conformity assessment body is the laboratory, the dimensional, the calibration body, or the inspection body. So that's what, when you hear me talk about CABs or conformity assessment bodies, it's the people that actually do the work. So if you look on this chart, you'll notice that we're probably going to talk most about 17025 for testing, calibration, and dimensional laboratories, and 17020 for inspection bodies. There's also the 17029 standard for verification and validation bodies. We're not going to talk about that as much. Some people find that closely related to inspection bodies. There are also certification bodies, which ANAB also does. We have our management systems group, which deals with 17021, our product certification group, which deals with 17065, and our personnel credentialing with 17024. Now, as we go through this, as we look at ISO 17025, we're dealing with the areas of technical competency, meaning we have to have personnel that have been trained properly to perform these tests, perform these dimensional calibrations, etc. We have to show that the methods that are being used have been validated. And by validated, that means that they've been shown to consistently produce valid results time after time after time that are replicable. We also have to show that we have, in the case of dimensional measurement, that we've got metrological traceability back to international standards and national standards of measurement. We also have to apply in 17025 what's called measurement uncertainty. Think of it this way: if you're measuring a piece of wood to cut, you're measuring it to, let's say, I want to cut a 12-inch piece of board. When you use a ruler or tape measure to do that, there's a certain amount of uncertainty based upon where you mark that line. In the case of 17025, whether it's laboratory testing or whether it's dimensional or calibration, there's a certain level of uncertainty based upon the precision that you bring to bear. And the last of these is ensuring the validity of results. And what that means is we're documenting every piece that goes into the testing that's used, whether it be the standards, whether it be the methods, whether it be the competency of the individuals involved, and the equipment used. So now let's talk a little bit about what's similar between these two standards. If you look at these on 17025 and 17020, we have the same basic structure, having general requirements, structural requirements, resource, process, and management systems requirements. And you say, well, Dave, what's the difference there? Well, it really comes to bear on the independence requirements for inspection bodies and the traceability for 17025 laboratories. And we'll talk about that independence and impartiality here in a couple minutes. With ISO 17025, You're testing to a very specific standard and you're producing very specific results. Now, 17025 laboratories can be either independent or captive operations. Independent means that they are independent of the organizations that they're doing testing for. Captive means they are part of that organization. You have to have technicians who are trained. You have to have specific sample preparation and test equipment setup. And for those of you that are familiar with 17025, that sample preparation and how you do that can have a tremendous impact upon the end results. You have to show that the tests that you're performing are replicable and that the parameters that you're using for these are able to be set up as well. With 17025, you're looking at identified results and also the ranges within which those results fall for acceptance or rejection. Now, with 17025, you're not covering regulatory requirements and you're not covering safety requirements. You're looking specifically at the test results, the dimensional results, the calibration results. In addition, with the dimensional and calibration, you're looking at the measurement of specific properties, whether that be length, operation, etc. Again, you're going to have trained technicians, you're going to have dedicated preparation of the equipment and setup. You're also going to incorporate what's known as PT, proficiency testing. Proficiency testing is where you participate with other laboratories around the world in blind testing to make sure that you can measure how the results that you're achieving compare to results achieved by other organizations, whether that be in Bangladesh, whether it be in Germany, whether it be in China, whether it be in Singapore, whether it be in Virginia. There has to be direct traceability to known standards. Earlier we talked about metrological traceability, but you may also have to have traceability to standards that are used, equipment that's used, materials and reference materials that are used. And one of the other things that is critically important is knowing what the laboratory conditions are, the testing, the cleanliness, the humidity levels, because those can have impacts upon the test results as well. Okay. Also with 17025, we've talked about traceability and replication, but they also have to be performed. These tests have to be performed to recognized or published procedures, whether they be international, national, regional standards, whatever. And if there is any deviation from the standards that are being used, not only do they have to be documented, they have to be accepted by the client and they have to be reported as part of that test report. There are very specific requirements for how results are going to be reported to the client in terms of test report. This is one of the key things from 17025. Early in my career, I was a design test engineer for jet engines, and when I would have items sent out to test laboratories, I would mark off 3 days on my calendar to go back through the test results, because at that time, this is before ISO 17025, it's before Guide 25, which was the precursor to this. Every test laboratory reported results differently. They may have their own test methods. When 17025 and Guide 25 came along, the standardization of reporting made it so that you can glean from an accredited test report the majority of the information in 3 minutes or less. It truly was a game changer in the engineering world, and many people don't pay attention to how much of an impact that's had. There's also the identification of who was the technician that's performing this, who approved the results, who went through them and looked at them and said, yes, this has been performed correctly. Also in those results, the measurement uncertainty is going to be reported. This is how accurate the result may be. And if something is being accepted or being rejected. That criteria is defined. So this is critical on the reporting of those results. Okay. Now with 17020, let's talk a little bit about that. One of the most important pieces of 17020 is the application of professional judgment. We also identify what are the operations and locations that these inspections may be performed. It's very different in how we are performing these inspections in that it requires the use of this professional judgment. Now, 17020 may be defined as first party, second party, or third party inspection. It includes the quality, administrative, and technical operations and management. And again, just like 17025, it does not cover regulatory or safety requirements. So let's talk about this a little bit. Let's define what 170 says is inspection. It's examination of a product design, the product, the service, the process or plant installation, and the determination of their conformity with specific requirements or on the basis of professional judgment, general requirements. So what the heck does that mean when you look at that? It means that with inspection, you may be looking at test results provided by accredited laboratories. You may be looking at the process of how an item has been put together. You may be looking at how an item was assembled. And then you're applying professional judgment as to whether this has been done correctly or not. So that's one of the best ways I can define it is through the application of professional judgment. Now, there are a couple different types of inspection, and let's take a look at that. There are two types of inspection. One deals with forensics, and one deals with non-forensics detail. The first type is the inspection of new products or looking at crime scenes or evidence for forensics. This is very detailed, and when we're looking at new products, we may be focusing on what are potential weak points in the design of an item and the production process of that item. The second is periodic inspection. Now that may be looking at the orientation on points of wear, corrosion, etc. One of the best examples of this is boiler and pressure vessel inspection. In most of North America, there's a requirement for boiler or pressure vessel inspection on an annual basis, looking at relief valves, looking at pressure points, looking at all of this. And even if you don't think about this, if you're in a building that has more than 4 occupied units, whether that be an apartment, whether that be a commercial building, whether it be an automotive dealership, you're going to have boilers and pressure vessels in there, and those areas have to be inspected on an annual basis. The third kind is what we call pre-shipment inspection. Now, inspection of goods before or after shipment, whether it's conforming with delivery notes. Let's take an example of this. One of these examples would be the inspection of agricultural products, grain, before it's loaded on a container ship or bulk cargo ship in the port of Novorossiysk, Russia, which has been tested, which has been identified, which has been sealed in a sealed cargo hold, and then it is shipped to Egypt for milling into flour and other items. And that inspection report, the seal on the cargo hold are accepted as a valid inspection if this inspection body has been accredited to 17020. Now, we talked earlier about impartiality and independence being critical within 17020. These are crucial for performing the inspection activities, and each of the three inspection bodies, we call them Type A, Type B, and Type C, describe different degrees of independence from the organizations that they are inspecting. So let's talk about that just a little bit. Type A is where the inspection body is a true third party. They're independent in all ways from the organizations that they're inspecting products for. This is the most common type of inspection body that we see, is a true third party. Okay. Type B is where it's an in-house inspection body only performing uh, inspections of products or activities that their parent organization is involved in, but they do have to show that they are completely independent of the rest of the organization in terms of how they operate an inspection. The third type is Type C. They may not be listed as a separate part within an organization like they are in a Type B, but there has to be a defined separation of inspection activities, meaning that the person that is involved in performing these inspection activities can in no way be involved in the activity that is involved with manufacturing, etc. There are some Type Cs that may also get involved with third party, but that's a separate subcategory that we won't go into today. Now, what are some of the common elements between 17025 and 17020? Well, they both have to define what their scope of work is. They both have to have impartiality from either the organization that they're doing testing for or the organization that they're doing inspection for. They have to maintain confidentiality. The resource requirements for personnel and infrastructure are the same. The requirements for subcontracting are very clearly defined, and the requirements for how they may handle complaints also has to be clearly defined. Okay. When we look at this, also we talked about management system requirements being common. The documentation of that management system has to be in place. How they control the documentation within that management system. How they control records of the testing, records of training, records of the inspection are common. The requirements for corrective actions and handling of corrective actions are similar. The requirements of internal audits and the range and basis of those internal audits are common. And the requirements that management reviews take place are common. Now, the elements that are covered in those internal audits and those management reviews may be significantly different, particularly in the areas of impartiality and independence. So we'll talk about that a little bit more as we go along. Now, key differences. Testing, when we're dealing with 17025, applies to materials, products, or processes. And normally we're going to get results which give us a specific value. For example, if you're testing something for potassium, you're going to get a certain specific result. This has so many liters of potassium, or it has this percentage of this item in it. And you're going to get an uncertainty associated with that. Now, also in testing, when we talk about risk-based thinking, you're talking about the risk associated with performing a test in a certain manner. Now, with inspection on the 17020 side, yet this applies to products that are being provided, it applies to processes, or it applies to services. One of the best ways I can describe this is a pressure vessel that is being constructed for recapture of gases on oil well and oil fields. When these pressure vessels are put together, they have to have certain steel that's been tested and has test results to it. They also have to have weld inspections that are performed. These may be radiographic inspections, they may be visual inspections. These all have to be performed in a specific sequence because as you seal up a pressure vessel, you can't go back in and do a visual inspection on the welds. You can't go back in and do a radiographic inspection on those welds. You have to do it as part of this process. If there's a water pressure test that has to take place for valves that are associated with it, it has to follow along this certain process. That's part of inspection, and when the inspector is looking at this, they have to have the professional background and knowledge to understand that if this is not done in a specific sequence, it's not going to be correct. We're also, with inspection, you're also looking at very heavy reliance on preventive action. How do you make sure that this process is being done in the correct fashion? Okay. Now, some of the key differences. One of these things that I get asked often is, well, aren't testing and calibration, aren't those all part of inspection? Yes, there is a big overlap between the inspection activities that go on under 17020 and testing, calibration, or dimensional that go on under 17025. The biggest difference is that with 17020, that inspection involves the application of professional judgment on the part of the trained inspector to determine, is this acceptable against the requirements that have been stated. That's a key difference. With testing or with dimensional, you have a clear defined acceptance or rejection criteria. That's not the case with inspection. It focuses heavily on the professional judgment of the inspector. Now, we said that we were going to talk about accreditation and the assessment process. So the hierarchy globally, and this applies to both the 17020 and the 17025 standard. At the top of this is ILAC and the IAF, who, while they do not write the ISO standards, they are the mutual recognition agreement signatory authority for all the accreditation bodies globally, basically saying, here's how we are going to assess to these ISO standards. The next level down is what we call regional cooperations, and examples of this are APAC, the Asia Pacific Accreditation Cooperation, and the IAC, the Inter-American Accreditation Cooperation. There's also the EA, the European Assessment or Accreditation. Then you get down to the accreditation bodies. These are the ANABs, the A2LAs, the PJLAs, the IAS, the DAX in Germany, the CINA in China, who do accreditations of conformity assessment bodies. And conformity assessment bodies are the laboratories, the inspection bodies, the proficiency testing providers, the reference material producers, those types of things. Now, what is accreditation? It is third-party attestation. So it's us as ANAB, as an accreditation body, saying you as a conformity assessment body, a lab, an inspection body, you have conveyed to us formal demonstration that you are competent to carry out the specific conformity assessment task. Well, that's a very technical thing. Basically says that whatever you have listed on your scope of accreditation, you've said, we're going to do this type of inspection, or we're going to do this type of testing. We're going to do it on these range of products, and we're going to use these types of standards. We as a third-party accreditation body have come in and we've seen that you're able to demonstrate that across your entire range of your scope of accreditation. And we're looking at how do you train your personnel, and we're using the tenets of ISO 17011, which we referenced early in the presentation, to perform this activity. Okay. Now, what is accreditation? It is the on-site conformity assessment by a technically competent assessor. Although in this crazy year of COVID or more, uh, most of those have been done remotely, and everybody's had to be able to pivot. It's assurance that the laboratory or the inspection body adheres to these internationally recognized standards. Now, those can be the ISO standards, it can be the processes or testing standards or inspection standards. We're evaluating the management systems and methods that are used. We're looking at, are those methods valid and are they appropriate? Is the equipment that's being used suitable? In other words, is the equipment able to test to the level of precision that's necessary? And in the inspection side, are the test results that are being evaluated, are they sufficient to make that decision which requires the application of professional judgment? We're looking at what quality control procedures are on site, and we're looking at the demonstration of the technical competency of the laboratory personnel, the inspection body personnel, anyone that is involved in that. Not just the technicians, but the people who do the oversight of this. Now, we also said we'd talk a little bit about conformity assessment. And without getting into this, and you can read this, it's a process for demonstrating that specific features meet the requirements of standards that are promulgated, regulations that are out there, other specifications. You know, for example, one of the things that we do under 17020 inspection is we do fire safety assessments. That not only involves compliance to the ISO standards, it may require compliance to NFPA 80 or 105, the National Fire Protection Association. It also may require compliance to what we call the AHJ, the authority having jurisdiction. That may be the county that this assessment is done in. It may be the city. It may be a small region of several states. Now, when we look at this, one of the things we want to talk about is what is conformity assessment, and it's demonstration that specified requirements related to a product, that would be a laboratory, a process, that would be inspection, a system, which is inspection, or that body are fulfilled. And that is how we define conformity assessment. So conformity assessment goes across the whole range of whether it is 17025 or 17020. Now, what is a conformity assessment body? This is the body that performs conformity assessment services. Now that sounds like circular logic, but it's conformity assessment body can be doing testing, it can be doing calibration, it can be doing certification of products, it can be doing inspection of processes, products, services. It can be looking at sampling. So a conformity assessment body can be a testing laboratory, a calibration lab, a sampling body, an inspection body, or certification body. Excuse me. Now, what is the difference between accreditation and conformity? Well, we as an accreditation body assess the competencies of conformity assessment bodies. And so we're looking at how do we make sure that you as a laboratory or as an inspection body are competent to perform the duties, the inspection, the testing that you do. Now, conformity is what you as a conformity assessment body do, where they may be looking at products and services, they may be looking at items for test, and you're saying, do these items conform to the standards that they're being tested to, the standards that they're being evaluated to, the standards that they're being inspected to. So that's the difference when we're called an accreditation body, it's ANAB, we're accrediting that you are capable and you have the confidence of performing the tests or inspections that are on your scope of accreditation. You as a conformity assessment body are looking at the products, the processes, the services, and rendering judgment upon those. Okay. Now, when we look at scope of accreditation, the 17025 and 17020 standards cover a couple specific things. With the testing laboratory, you're looking at what's the field of test, what are the types of tests, what are we testing, the test object, what are the parameters, what are we looking at, what field do we want to be looking at. We'll reference the standard method, and we may reference an internal method. Okay, calibration laboratory is very similar, but in addition to this, we're looking at the traceability of the calibration, and we're looking at the calibration and measurement capability, what we talked about before with the measurement uncertainty. To what level of precision or what level of uncertainty can this item be calibrated or tested? Now, with inspection bodies, what we define is what is the conformity assessment activity, what type of inspection is going to take place. Then we define what are the items, the materials, the products, the services to be inspected. We define what that type of range of inspection is. We look at what the methods and procedures are. One of the other things that is clearly defined is what is the location where this inspection is taking place. Now, why is this critical? Because there's a basic difference between testing and calibration laboratories under 17025 and inspection bodies under 17020. When you're looking at 17025, normally all the activities take place in a laboratory in one specific or two specific locations. Inspection bodies are completely different. When there's a headquarters for an inspection body, often it's two or three people. All of the activity takes place remotely. It may take place in a port. It may take place in an oil field. It may take place at a refinery. These inspection activities take place in very dispersed areas. It's very different than when you're thinking about testing or calibration activities. Inspection bodies, by their very nature, are dispersed. Now, when we talk about location and we talk about location code, the reason that that is critical is because one of the things that we as a accreditation body look for is, do these inspection bodies have trained personnel in the areas where they're performing inspection, and do they have the capability to look at those particular items on the scope of accreditation. Okay, now we also said we'd talk a little bit about the accreditation process, and I don't want to get into this in great detail. Basically, when somebody decides they want to be accredited, they make an application to us as the accreditation body. We will give them a quote on what it's going to cost. They submit documents to us for review. Once that's gone through, we go through an accreditation assessment. Based on that, we may be issuing corrective actions. Once those are addressed, we'll go through a technical review. In our case, it requires at least 3 different levels of technical review, each independent of the other. We go through an accreditation decision and decide to either grant accreditation or not. And then we begin a cycle of surveillance and reassessment, with that surveillance or reassessment taking place each year. Okay, what are some of the benefits of accreditation? There's demonstrated competency in the field in which you're accredited, whether that be testing under 025 or inspection under 020. There's an international recognition of the methods that are being utilized. There's enhanced public confidence in the measurement results. Now, and that sounds like something, pie in the sky stuff. The world we live in today, where we have products, let's say your television set, where you have LED screens which are produced in Japan, and you have components which are produced, electronic components, in Malaysia. Those products are then put together in China, and then they're tested by an independent laboratory. Then they're packaged up and they're shipped here to the US, or they're shipped to England. And that testing, which has taken place in other countries around the world by ILAC MRA signatories, is accepted here in the US. 30 years ago, that did not happen. The world we live in with global trade relies upon this. It reduces the errors that are inherent in this process. It gives us increased accuracy, and above all else, it gives us cost savings. When we talk about, products being reduced in terms of overall cost, we do this through testing, we do this through feedback, we do this through this process of ISO accreditation. Whether it's for testing from 17025, whether it's for inspection under 17020, the goal is common. Now, you notice that on this we've got right standard in parentheses, and the reason for that, what are some of the key factors in selecting what we call the right standard? Well, if you're looking at professional judgment, that's 17020. If you're versus measurement results fall under 17025. You're looking at inspection process versus an analytical test. The inspection process falls where you're looking at how something is put together. What's the process this occurs in? That's 17020. An analytical test clearly falls under 17025. Conclusions versus data. Conclusions fall under the realm of professional judgment, which is the application of professional judgment, which is under 17020. Data does not come from 17020. Data comes from 17025, from testing, from calibration, from measurement. The other deciding factor is what is the level of independence that is necessary in the field that you're pursuing. With independence and impartiality, that is required in both 17020 and 17025. Okay, there are additional resources. I'm going to turn this back over to Emma at this point in time.
Thank you, Dave, for that wonderful explanation of the 17020 and 17025 accreditation requirements or standards. So we do have some additional resources for you. If you have any questions or you want more information, you can certainly look at those additional resources that we have available on our ANAB website. We do have a few questions that have come through, so if you have any questions at this time regarding the presentation or any questions regarding 17020 versus 17025, please don't hesitate to put those in the chat pod. But one question that did come through, Dave, for you is regarding the use of professional judgment. And if you could expand on that concept or on that idea of using professional judgment and give an example on how that is used more heavily in 17020 versus 17025.
Okay. With 17025, what you're presented with is you're presented with a concrete piece of data. This particular item tests at this level of concentration or parts per million. And you're given a range of what's acceptable versus not acceptable. Okay. With 17020, we talked a little bit earlier about pressure vessels and start with this. In order for someone to be doing inspection on pressure vessels, they have to have a background in certification through AWS, the American Welding Society. They may have to be able to interpret radiographs, X-rays. They may have to be able to have the knowledge to interpret pressure readings. They may have to have the ability to read blueprints or CAD drawings. And to be able to follow that sequence through, they have to have the knowledge of, are these things being done in the correct order? Not only is this the correct grade of steel, not only was this, did this weld show no voids, and it was tested by a level 2 technician, but as those things are put together, does it make sense from a professional level? One of the key things that we look for when we have 17020 assessors is we look for specific areas of knowledge and expertise. If I've got somebody looking at the at building codes and specific to New York City, specific to Philadelphia, specific to Henderson County, Nevada, I've got to make sure that that individual has the training and the background in those areas that has the ability to interpret those things. They can't just understand 17020. They have to understand that process, that technology, that application. The same thing on the forensic side of 17020. They have to understand the application on the forensic side, how it's utilized by various departments in the field. I hope that addresses the question.
Yes, thank you very much. A few more questions have come in. One question is, could there be instances where you're actually accredited to 17020, but you need to perform a test? What do you do in that situation?
Absolutely, that occurs in many instances. We actually have any number of organizations which are accredited to both the 020 standard and the 025 standard as testing laboratories. There are also many inspection bodies that utilize the services of accredited 17025 testing laboratories. Part of what the inspection bodies are required to look for is the validation of the test results from an 025 laboratory. Hope that answers the question.
Yes, thank you. There are a couple of questions regarding forensics, so I'll take those questions for you,
Perfect.
Dave. It says, I know that some forensic laboratories have moved their comparison disciplines to a 17020 accreditation. How are those being considered inspection bodies? What about their testing moves them to an inspection realm? And so that's an excellent question because I know that many forensic laboratories struggle with that. And there are some comparison disciplines like friction ridge or firearms that have moved to a 17020 requirement. In this case, the requirement that they're inspecting against would be their own procedures. So they still have their procedures that they use to perform the analysis on that item of evidence. And they are using then their professional judgment to come to their conclusions regarding what that means and what they've evaluated. For example, for crime scene folks, and I know this isn't a comparison discipline, but for crime scenes, we consider the product the crime scene, and you're then evaluating that product or that crime scene against your requirements or your procedures. And in this case, you're not generating the test, you're not performing the test at the scene, but you're going out and using your professional judgment on how you actually go out and investigate that scene, identify the evidence, and collect the evidence and keep the evidence for safekeeping. So great question on how some of those disciplines may fit into that 17020 requirement as well as the 17025 requirement, because there are many labs that use 17025 as well. There's another question for forensics. It says, can you explain fit for purpose requirement in 17020 with respect to crime scenes? And this follows what I previously said, that as an inspection body, you're using your procedures as the requirements for how you go about doing the work at that scene where the scene is your product. So for you, it is fit for purpose. Is it actually, are you meeting your requirements of your procedures? And is the work that you're doing fit for purpose to meet your customers' needs? So I hope that addresses that question. One additional question for you, Dave, says, please offer an example of risk-based thinking as it pertains to testing.
Okay. Risk-based, I can talk. Risk-based thinking is you're looking at specifically what are the risks involved in any type of testing that is being performed and any type of activity that is being performed. When I look at risk-based thinking, one of the ways I like to talk with laboratories about this is take a look at what are the top 20 to 30 risks to your business. What are the top 20 or 30 risks and probabilities of what can happen? And that could be that you're not going to have enough technicians to perform the test. It could be that you don't have the proper technology in place to perform the testing. It may be that you've got something that we're seeing a lot right now. You're having supply line disruptions where you cannot get the chemicals or the reagents that are necessary. And you go through and you rank those based upon, I call it do a 1 through 5 severity. 1 being, yes, that could be a problem with performing our tests, but it's not going to cause a severe impact. We can figure out ways around it. 2, if you rank something as a 5, this is something which is going to cause us to go out of business or cause us to completely fail this test. So you go through and you look at what are the risks to your business? What are the risks to your testing? And you say, okay, which ones are 1s, which ones are 2, which ones are 3, 4, 5, and that gives you that gives you a roadmap by which you can attack potential problems. And it gives you, that is your risk-based thinking. You can call it your risk priority. Um, and that risk is not defined by somebody else. It is defined by you. So think of it that way. Think of what are the top 25 to 30 issues that you can see coming up with your business. Could it be that, could it be that one of your primary customers may pull their business, that there's competition to you? And you look at that and you rank them in severity from one being low impact to five being critical impact. That's what we look at in terms of risk-based thinking.
Excellent. Thank you, Dave, for that explanation of risk-based thinking. There are a couple more questions that have come in. I think one is related to one that has already been addressed about testing that might come up when you're performing an inspection. It says many inspections involve testing at sites in ambient conditions. Where does that get covered, such as concrete or PVC pipes with hydrostatic testing in process?
Okay, so that's pretty straightforward. Um, the testing that is being performed, particularly on hydrostatic testing, you have to show that the personnel performing that test are trained. You have to show that the calibration of that equipment is traceable. This is one of the things with inspection bodies that we run into quite a bit, is that the requirement for traceability transfers to the 17020 inspection bodies if they are using that testing to make a decision on. As if it's just a reference and it's not being used to make a decision, that traceability component may not be there. As soon as an item is used to make a decision for an inspection, that traceability component and that testing requirement component is there. Now, let's say, for example, that somebody was one of the inspectors had to read a hydrostatic pressure. Um, not only does the inspector have to be trained in how to properly take that reading, but they're also going to look at the procedures behind that to see if they've been validated. Are they doing the setup correctly? Are they doing the pre-pressure hold correctly? Is the timing, is the bank down being done correctly? Those are all important questions. We've had a number of different organizations which we've said we cannot give you accreditation for this item on your scope of accreditation because you're not demonstrating that these valves that you're taking pressure from and you're making a decision on, you're not showing that those have been calibrated by an accredited source, even though you don't own them, even though they are not technically your responsibility. As soon as you use them to make a decision, that becomes impingent upon you to make sure that that is done. Otherwise, you can't use that to make a decision. Okay.
All right, thank you, Dave. We are out of time. If there are any additional questions that you have, please don't hesitate to contact us. Here's some additional contact information. If you have questions about training, if you have questions about accreditation or questions about accreditation services, the email addresses are listed here. So thank you all for your participation. It's been wonderful. Thank you for those wonderful questions. And I hope you have rest of your day is lovely. So thanks, everyone.
Thank you for facilitating, Emma.
You're welcome.